I'm here at West High School with Science and PTLW teacher, Mr. Pugh. Mr. Pugh, how much experience do you have with 3D printing?
Quite a bit, I would say. Not maybe as much as someone that works in industry, but we've had a 3D printer here at West since 2004.
Okay. And since 3D printing has become part of the educational system, how much do you think the educational system has changed?
It's changed quite a bit. I know for me and my engineering students, when they were doing design work, if they wanted to see an actual model of it, then they would have had to gone to the woods room or gone to the metal shop, and they would have had to have made it, physically made it on the machines. And some of our kids don't get safety tests, they don't go through those programs, so a lot of them don't have a lot of experience with the tools that they need to use. Now, when they're working on their projects and they want to get a prototype, we can send it to the 3D printer. So now it's a lot more accessible, and it's easier for them to get prototypes in their hand to see how things function and work. I do have examples if you'd like to see a couple, and we can do that.
Oh, sure.
As you can see, this is one of my senior project group, senior presentation projects. And what they did is, the problem they wanted to solve was, you have multiple video games and you want to play a different video game, but you can only run one through your TV at a time. So their problem was that people had to unplug cables, plug cables in, and they found out that a lot of people end up knocking their TVs over, damaging their TV sets or damaging their games. So they designed a box that you could plug all your games in, and then by turning a switch, you can turn on which game you wanted to play, and it'd already be hooked up to the TV. So you never had to move the TV, you didn't have to move any of the games. Well, when they were in the process of designing this, they had a lot of things that they wanted to be able to do. They wanted power in it, they wanted their video, audio ports, and as they worked, they were able to print sections off to test to see that what they had designed and what they had dimensioned and made an inventor was actually going to work before they did a final run on their prototype. This is their first prototype, but again, if they wanted to build this and we didn't have a 3D printer, they would have to go to the shop classes or go somewhere and manufacture all this. And knowing that it's going to have electricity, it's going to have circuitry inside of it, it can't be anything that can conduct electricity or could be damaged by heat. So obviously metal's out of the question for power because it's a power strip. They wouldn't want to use wood because it holds heat too much. It's a great insulator. So being able to print it in plastic, that would have cost them a lot of money to go to an engineering firm and have them do that for them. So because of the fact that we have these in school, now these students who are learning and creating and coming up with solutions to problems can actually take their ideas and make them real and actually do testing on it to see how they work. It makes it more efficient because even if they were to go to the metal shop or wood shop to build this out of wood or metal for their prototype, the time it would take to do that would be a lot longer than what it took to run it through our rapid prototyper. Granted, it's not a fast job. This particular job took about 15 hours to print. But versus how many days were they going to have to spend in the wood shop and the metal shop creating the same thing?
Right.
With all the extra finish work to get it all to where it was good and usable. Where when you print it in a 3D printer, it comes out pretty much ready to go.
So at Christmas Golf Academy, we have a MakerBot 2, and it is 9 by 9 by 12. How does yours compare?
We have a build envelope that's 10 by 10, XY axis, and then 12 inches tall in the Z.
Okay, so you can generally just build bigger things then?
We can build bigger stuff, or more stuff inside.
And how does the support compare? At Christmas Golf Academy, ours is a breakaway support, which means that we just have to pick it off.
Where yours is breakaway, you peel off the support material that it uses to build your model. Ours is actually a soluble support material. The parts come out and we can still break away just like yours if the part warrants that we can do that. But if there's support material built in such a way that we can't get to it, we do have a tank that we can put it in with a weak solution of sodium hydroxide, which will dissolve the support material out.
And is that more expensive? Is it built into the machine?
It's just part of the machine. Not this particular machine, the tank with the solute support, the sodium hydroxide, is a separate tank. But as far as the workings of the machine, they're identically the same, we just use a different material for our support.
Okay. Our MakerBot 2 was just over $2,000. How much was this when it was all said and done?
We purchased a storage base with this. We also, got a service plan for a few years. It came with the material that we would need for our classes. All being said, it was probably right around $30,000.
$30,000. Because 3D printing material prices are going up, do you think that could potentially cause a market crash in the future?
I don't think so. I think it just opens the door to more creativity and design, allowing people to come up with newer ideas, being able to use a wider range of materials instead of just ABS plastic, being able to take that to the next level and being able to, again, to prototype quickly and efficiently versus someone making their prototypes by hand.
And finally, dangerous items can be made with 3D printing. Do you think that could cause them to be kicked out of schools entirely?
Ultimately, the 3D printer it's in my classroom. It's a piece of equipment we use in class. My engineering students know what's right and what's wrong. I know sometimes students don't always make the wisest of decisions, but again, that machine, anything that's printed on that machine has to go through me before it ever gets to the printer.
Okay.
So if someone was to want to print something that was not school appropriate, obviously that's going to get caught by me, and it's never going to have a chance to get printed.
Right.
So.
All right. Well, thank you for your time, Mr. Pugh. I'm Taylor Morris from Chris McCall Academy, signing off.